Hi guys, in this tutorial I'm going to solve the question number 7, paper 42 March 2021. We have two particles P and Q of masses 0.5 kilogram and m kilogram respectively are attached to the end of the light inextensible string, and the string passing over a smooth pulley which is attached at the top of the two inclined planes. The particles are initially at rest. We started from rest. And P on a smooth plane makes an angle 30 degrees to the horizontal, and Q on the plane inclined 45 degrees. The string is taut and the particles can move on lines of the greatest slope of the two planes. So a force 0.8 Newton is applied to P acting down to the plane, causing P to move down. So this is the direction of moving of P. So this is the direction of moving Q. So given that the mass M is 0.3 kilogram and that the plane on Q is rest, it is smooth. Find the tension in the string. If we try to solve like this question, by using forces, Newton's law. First, you can write the equation of particle P, then write equation of particle Q, then you can add to get the equation of the system. For particle P, all the forces in direction of motion, it's 0.8. What else? The component of the weight, mg sine theta, minus opposite, it's a smooth, there is no friction force, but we have tension in opposite side is equal to MA. Equation of particle, you can substitute by the given information, like 0.8, mass is 0.5 multiplied by 10, multiplied by sine 30, minus tension is equal mass 0.5 multiplied by the acceleration. Second equation for particle Q, move up because of tension, minus mg sine theta. We don't have also any friction force, it's written smooth, so is equal to MA. The tension is not given, mass in this case 0.3 times 10 times sine 45 degrees is equal to mass 0.3 multiplied by the acceleration. So the equation of system, but you can write a direct equation of system by adding. If we add, we'll remove tension minus T and plus T, then 0.8 plus 0.5 multiplied by 10 times sine 30 will be 0.5 multiplied by 10 multiplied by half, minus 0.3 multiplied by 10 multiplied by root 2 over 2 is equal to 0.8. You can solve this equation to find the value of acceleration. 0.8 plus 0.5 multiplied by 10 multiplied by 0.5 minus 0.3 multiplied by 10 multiplied by root 2 over 2, root 2 divided by 2, equal, then divided this answer by 0.8, you will get the value of acceleration 1.4733. If we substitute in this equation by the value of acceleration, you can find the tension. Tension is equal to 0.3 multiplied by 10 multiplied by sine 45 is equal to 0.3 multiplied by 1.47 multiplied by 0.3. Then when it's moving to the other side will be plus 0.3 times 10 times sine 45. So the value of the tension will be 2.563 Newton. You can solve this part also by using energy and power. If we go to part B, it's given that instead of the plane Q rest is rough. So now we have a frictional force. And after each particle has moved a distance 1 meter, their speed 0.5. The work done against friction in this part is 0.5. Use an energy method to find the value of M. We can try to solve part B exactly same like part A, write the equation of particle P, write of motion of particle Q, then try to solve the equations, but it's written use energy method. Let's start to write equation of each particle, then write equation of the system by using energy method. Start with particle P. Particle P move in this direction. The work done by the tension or by the force 0.8, the work done by all the forces in direction of motion, but all external forces acting on the particle P. The external force act on particle P is 0.8. So the work done by this force 0.8 minus the work done against resistance, the work done against motion. What is the force acting in opposite direction? Just only we have tension, it's still smooth. So the work done by tension is equal to a change in mechanical energy. The work done, the net work is equal to a change in mechanical energy. The net work or the work done is equal to a change in mechanical energy. The work done, we split it into work done by the force 0.8 minus work done by tension. And the change in mechanical energy, we will split it into two parts. A change in kinetic energy and a change in potential energy. A change in kinetic energy, in this case, gain, because it starts from 0 and end with 0.6. But potential energy go down, so it represents a loss, mgh. So now, if you try to write the equation of the particle P, work done by the force 0.8 minus work done by tension is equal to change in mechanical energy. First, it's a loss. Loss means negative, mgh, where is h the perpendicular height. And the kinetic energy now is gain, kinetic energy have mv squared. The work done by the force 0.8 is equal to the force times distance, which is 1, minus the work done by the tension will be tension times 1. So leave it, because when we try to get the equation of the system, you will get a work done by tension positive and work done by tension negative will removed. Negative mass is 0.5, 10 g. Where is the perpendicular height? When you move a distance 1 meter down, let's say this is 1 meter down, and we already have the angle of inclination, which is 30. To get the vertical height opposite to 30, so will be 1 sine 30. 1 sine 30 will be half, or 0.5. 0.5. Plus gain in kinetic energy is half, mass 0.5, and velocity 0.6 squared. This is the equation of the particle P. From this equation, you can find the work done by the tension. But leave it, no need. We'll try to add to get the system. Now for particle Q. Particle Q move up under the force of tension. So the work done by the tension minus work done by resistance, or we can say against resistance, same, a change in kinetic energy, potential energy, kinetic energy, and the potential energy. For potential energy, in this case, gain. The particle move 1 meter up. So to get the vertical height, if this distance is 1, this angle is 45, so use 1 sine 45, you will get the perpendicular height is √2/2. mgh, it's again, and also have mv squared, it's again. So when you substitute in this equation, the work done by tension, the work done against resistance is equal to 0.5. It's given in the question 0.5 is equal to, mass is not given, G is 10, perpendicular height is √2/2, and have mass is not given, velocity is 0.60 squared. When we try to get the equation of the system, you can calculate the work done against tension or work done by tension from the first equation and substitute in the second equation. Or if we try to add the equation of particle P and the equation of particle Q, you will get the equation of the system by removing the work done by tension. So the work done by the force is 0.8, which is 0.8, minus against resistance, which is 0.5, is equal to the change in mechanical energy for the whole system. For this part, it's a loss, and this part, it's a gain, but it's not equal. So you have to combine, and you can add all the right side together. You can calculate each value, then write it down, then simplify and write your answer in terms of M. So if we simplify only the first part, simplify 0.5 multiplied by 10 multiplied by 0.5. So the first part is -2.5. Second part, 0.5 multiplied by 0.5 multiplied by 0.6 squared. So this answer is 0.09. Plus, when we simplify, will be 5√2m. Simplify this part is have times 0.6 squared, which is equal to 0.18 Now, if we simplify this equation, you can calculate the value of m. It's 0.8 minus 0.5 plus 2.5 minus 0.09 is equal to, then divided by 5√2 plus 0.18. So the answer will be 0.373738. Correct to the nearest 3 significant figure will be 0.374. This is the value of mass of the particle. That's it. Thank you.